All right, guys, welcome back. So we're going to talk about compound inequalities. I failed to mention that in the first lesson video. That's why it was a little bit smaller. And we're also going to talk about absolute values and how do they mesh in with all of this. Okay, so go ahead. This is the and compound inequality definition. So if you want to go ahead and write this down. Okay, I will say the important thing that you're going to need out of this definition is just the bottom part here. Okay, what does it look like visually on a number line and algebraically? Okay, so as I'm trying to find my notes for today's lesson, here we go. Should have had this on hand before, so sorry about that. But if you look at an and compound inequality, there we go, that's what we're going to start with. You can see that it has to satisfy both requirements. So for instance, looking at the example, it has to be less than 3, but it has to be greater than or equal to 4, which is indicated by the closed circle and the symbol over here. Okay, so two things that have to be true. Let's take a look at one problem together. All right, so solve the following. Compound inequality. We're going to write in set builder notation, and we're going to go ahead and solve it on a number line. Represent it on a number line. So if I were to just block this section of it, I would solve this normally just like a previous inequality, but now I have this guy attached to it. So whatever I do to one side of the inequality expression, I have to do to the other side. Because once again, it's a balancing act. Okay, I cannot increase the value of one side and keep the other the same. Okay, it's not going to be the same inequality anymore. So when I add 2 to both sides, it looks like this. Okay, I still want to solve for y. So 12 less than or equal to 3y less than 19. Oh, not 19, 21. Sorry, forgot to add those. And divide everything by 3 to get y by itself. So 4 less than or equal to y less than 7. Okay. Now, as a set builder notation, okay, we would say all y values, given that the values are in between 4 and 7, including 4, could write it in this fashion. This is an and compound inequality. So you could put and instead. There's two ways of writing it. Personally, let me just in case it gets blocked by the camera. Personally, I kind of leave it in this method here, and that's what you're going to see. And it's just an extra thing to add to the set builder notation, not really required. This is already implied up here. Number line, here's 4, here's 7. Okay, 4 gets the closed circle, 7 gets the open, not allowed to be equal to it, and you have to be between those values. So 5, 6, 7, I'm sorry, 5, 6, 5.5, 5.75, okay, 4.333 repeated. They are all satisfied in this equation. Okay, so there's an and compound inequality problem solved. You could, if you want, I think it's more work personally, you could just break them apart and solve this one individually first, and solve this guy individually, and then combine the answers. Okay, if that works for you, feel free to. Okay, we're going to jump to the or compound inequality. Once again, the important part is here at the bottom. Okay, it has to satisfy one of these requirements for it to be a true statement. And notice in or inequality, they go in opposite directions, your ranges. Okay, so for instance, x has to be greater than or equal to 5. Closed circle, going in the right direction. Less than -3, once again, open circle this time, and the other direction, which is going to the left. Okay, those are all the range of values that make this inequality true. Okay, so let's try and solve one of these. We have x plus 3 less than 2, or negative x less than or equal to negative 4. This is already separated into two inequalities, so this won't be too bad. We'll solve each one individually. Subtract 3, we get x is less than negative 1. Over here, we have to divide both sides by negative 1. And if you notice, negatives come in. That means I got to switch the sign, right? Or it's not going to hold true anymore. So x has to be greater than or equal to 4. Now, just because I switch the direction of the sign doesn't mean the equal to is gone. It still remains. Okay, that does not change. Put the or right here in the middle. Okay, so that way it's good. Set builder notation. We want all x values given that x has to be less than negative 1 or x has to be greater than or equal to 4. Okay. Now, unlike this guy, you didn't need the and. Here you must have the or. You don't want to list it. Okay. I mean, if I were to erase this and put a comma here, I don't think that's entirely awful, but you really should have the or symbol there. So that way it's distinguishable as to what solutions work for this inequality. Okay. So if I can go back in time and scratch up what I just said, I would. So leave the or in there. Number line, negative 1 and 4. Okay, 4 I'm allowed to have, and you have to be greater than 4. Negative 1 I'm not allowed, but I have to be less than. How do I know if that's correct? Well, plug in numbers. Okay, if I plug 5 into here, is 5 plus 3 less than 2? Ooh, no, it isn't. But let's look at the other one. Negative 5 less than or equal to negative 4. It is. So see how it still satisfies one of those guys. Okay? And that's the important part. Questions, thoughts, concerns, dilemmas? Hopefully not. This should be a review from Algebra 1. That's the goal. Let's incorporate absolute value. Here's where, give me a minute. Give me a minute. Hold on. Change it up. Okay. Now let's put it all together. If you recall, absolute value means the distance a number is from 0. But now with an inequality, does that change anything? Technically, no. Here's what it really reads as. Okay, let's put some words to this. So this means that the distance between D and 0 on a number line is less than 2 units. Okay? And I highly encourage you to write that in your notes. That's what that inequality statement reads. Okay? I'm still calculating distance, but now I'm looking at a range of distances that are less than 2. I'm not going to solve this one algebraically. I'm just going to look at it on a number line. Okay, so here's 0. Now let's think about this. What is like the max number I have to write that I would write on the right-hand side here? Keeping in mind that the distance that this number has to be is less than 2, would be a 2. Right? That's the max. It can't equal it, but it can't go past it. 3 is 3 units away from 0, and that isn't going to satisfy this, right? And then negative 2 on the other side. Because remember, absolute value, we're looking at left and right on the number line. So if I plug a negative 1 into here, is negative 1 less than 2 units from 0? Yes. Is a positive 1? Yes. Is a half? Yes. So what I'm looking at here is all of these numbers in between negative 2 and 2, but I can't include those two numbers because there's no equal to sign there. Okay? Does that make sense? So we're still talking distance, but now we're looking for distances less than or greater than. the number that's on the other side of the inequality. Okay, let's try another one. And then we'll talk about how to solve this algebraic. So 3 less than the absolute value of d. Now, how would I write this? Well, it would be the distance between d and 0 on a number line is greater than 3 units. So I'm looking for distances that are bigger than 3 from 0. Okay? So let's draw a number line again. Here's 0. So I want numbers bigger than 3. So my starting is probably going to be 3. And then over here it would be negative 3, right? So if I want numbers whose greater than 3 as a distance. So 3 can't be included, but anything beyond 3 would work for this guy, right? So 4, would the absolute value of 4 be bigger than 3? Yes. The absolute value of 1,000? Yes. Now over here, I'm going to look at the other side. Negative 3, any values less than that would work. Think of it this. Would negative 5, the absolute value of negative 5, be greater than 3? Yeah, because remember, absolute value takes the opposite of the number inside of it. So all of these values would make this work. Okay? I really hope me writing this down is making the visual easier to interpret. Okay? And keeping in mind, there's more than one solution to an absolute value. Possibly, depending on the equation itself. Okay? Now, one thing I want to make a quick observation on before we jump into how to solve this algebraically, because let's face it, okay, I always put more examples in there, sorry. You know, we're not going to just have an absolute value on one side that's just a variable and the other side a number. It's going to be a little bit more complex than that. Look what this says, and it's what we just did. If your absolute value is greater than the number that you're looking at, it becomes an or statement. If the absolute value is less than the number you're looking at, it becomes an and statement. Did that happen here? Less than became an and statement. Greater than became an or statement. It did. Now, would I require you to memorize that? No, absolutely not. This is just an observation that we created by looking at just some basic examples. Okay, we're just testing out what absolute value inequalities look like before we, ramp up what we could add to this, right? We could add numbers to both sides. We can add more on the inside of the absolute value. But I think starting with these basic examples, it really hits home what we're really looking at here. So that's all that this is. So we don't necessarily have to write that down, but just to make that observation. Okay, if an absolute value is less, you're going to see an and. If it's greater, you'll see an or. Okay. So first problem we're going to try out. Okay. We are still talking distance. This guy, whatever it comes out to be, this number has to have a distance that's greater than or equal to 4 from 0. Okay? Just like absolute value before, there's always two cases. The first case, I don't change nothing. I leave it as it is. Inequality symbol stays the same. The number to the right stays the same. On the other side, it changes. And the change was this number, right? We took the opposite. I don't say negative because if it's already negative, it doesn't become positive, right? Opposite's a better word. But what do you think I do to the inequality symbol? I switch it. That's the big difference here. Okay? So, you have to change the inequality and the number next to it. So that's the important part. So, should we put words to it? So you have to change the direction of the inequality sign and take the value after the sign, take the opposite of the value after the inequality sign. Something like that. So you change the direction, okay, and you still take the opposite of the value. Now you could probably English that better, word it better, to your own liking, but it's always good to have some words next to what you were doing. Okay, we solve these individually just like before. Add 2 to both sides, so 2x greater than or equal to 6. Divide both sides by 2. X has to be greater than or equal to 3. On the other side, we'll add 2. So 2x less than or equal to negative 2. Divide both sides by 2, we get x is less than or equal to negative 1. On a number line, let's see what it looks like. Okay, I'll just put those values there. Someone asked me, do you have to write all the numbers in between here if you're doing a number line? Not technically. You could just put the 2 numbers you're interested in. Because here's the deal. If this was negative 90, if this was 100, imagine writing all those numbers out. It's insane. So it's okay to just put those 2 that are your range values. Okay. 3 can be included. Negative 1 can be included. And I want numbers greater than 3, less than negative 1. So this became a OR statement. Okay. It's an OR graph. The other way we could look at it, given all x values, given that x is less than or equal to negative 1, or x is greater than or equal to 3. So you could write it with set over notation. Okay? But that's the big difference. And my hope is that starting with those 2 example problems that we did, we've already seen what the graph looks like and what it looks like on a number line. All those things put together explain why we do this. Okay? We switched the inequality symbol so we could look at the other range of values, and we got to change the number. Take the opposite of it, whether we start from here to here or vice versa. Okay, there's a reason why we do that. All right, there's one down. Let's do another one. Okay, so we'll start with this guy. And then we will do some word problems to wrap it up. Always encourage you to solve this on your own before you see what I did. We have 2 cases, one that does not change, the other one that does, and we take the opposite of the symbol, the inequality sign, and opposite of the number. Okay? Like I said, I think the word opposite is a better word to use. Add 3 to both sides. 3x is greater than 12. Add 3 over here. 3x is less than negative 6. Divide both sides by 3. I get 4. Divide both sides by 3. I get negative 2. I solved them both at once. You could solve these individually. You don't have to solve them at once. And I think, if we look at our options, it's going to be what? A? For this guy, right? Here's the set builder, here's the number line, and that matches what I have here. Okay? Not bad. Okay. Let's go ahead. Let's do a word problem. Job hunting. To prepare for a job interview, Hendo researches the position requirements and pay. She discovers the average starting salary for the position is $38,500, but her actual starting salary could differ from the average as much as $2,450. Write the absolute value inequality to describe the situation, and we're going to solve it. Now, a couple things. One, could you just add or subtract from here to get your range, and that's good enough? Yes. That's not the point of this problem. The point of this problem is can we use proper math symbols and notation to represent this, okay? And if you start now understanding what this means and how to translate it, when you go further along in your math career, you're going to discover problems with absolute values and with more things involved, but knowing the basics is going to make it easier for you, okay? So, the distance or the difference, if you think about it, between the average and what you could get, I want to put an absolute value there because once again, if my starting salary is larger than this, don't I get a negative number when I subtract? And we're not talking about negative money, we're just talking what's the difference going to be. So I could start with $38,500 and I'm going to subtract my starting salary. And once again, if it's larger, that's okay. The absolute value takes the opposite, so it's not going to be a negative difference, okay? And then as much as $2,450, I don't want it to be larger than that. So it's going to be less than or equal to $2,450, okay? So this is as much, okay? So this is the difference between our two salaries. This is the average, and this is my starting salary. Okay? Now we just solve it. And we're still going to get the same answer if I added or subtracted the difference to the average, but doing this is pretty important, especially for those who want to start doing some computer programming. You need to know how to do some translation stuff here. Okay. 38,500 minus x less than or equal to 2,450. And then on the other side, same thing with some differences. So I guess not the same thing. Change the sign and do the opposite of the number. Okay? Subtract this over the other side. So negative x, okay? Oops, sorry. Less than or equal to negative, or I'm sorry, not negative. It would be, or it would be negative, right? Yeah, 36,050. Sorry, I was looking at my notes to confirm. I'm like, wait a minute, no, it is negative. Divide both sides by -1. Be cautious because we're dividing by a negative. We're going to switch the sign. That could happen. I know we switched the sign over here, but the sign switched over here because of the negative. You got to keep those rules in mind. Just because you switch it once doesn't mean you're done. It just depends on the equation. So my starting salary is going to be at least $36,050. Could be bigger than that. Where's the ceiling at? Okay. Well, we subtract this to the other side. So we get what? Negative $40,950. Divide those sides by -1. Keeping in mind, we have to change the sign again. So x is less than or equal to 40,950. Okay? So there's my ranges. So on a number line, or, tell you what, we'll do set builder. I think it'll be a little bit easier to see. So x values, okay, given that x has to be between two ranges, 40,950 and 36,050. So that's what she could be starting with. Her average starting salary could be anywhere between those values. Okay? All right. I think we should do one more and we're done. Okay? The average birth weight of a newborn baby is 7 pounds. However, this weight can vary as much as 4.5 pounds. Man, is that high? But that makes sense. I mean, you could have complications. Baby could be born early. What is the absolute value inequality to describe the situation? So that's all they want us to do. Just what is it? Okay? So let's think about this. What is the average weight of a newborn? 7 pounds, right? Okay. So I start with 7 pounds. I'm going to subtract my weight, not mine, the baby's weight that I had, okay, from 7 pounds, and see what that difference is. Doesn't matter if it's negative, right? The absolute value takes care of it. And it can vary as much as 4.5. That's the largest. So it's going to be none less than or equal to 4.5. If they said could vary as little as 4.5, then I would switch the inequality sign. That's the least value that it could be. Okay? So it looks like my proper answer is going to be what? D for that guy? Okay? Now, could we solve this? Yeah, let's solve it. Why not? It's already here. First case, nothing changes. Second case, we change the sign and take the opposite of the value afterwards. Okay. Subtract 7. Okay, we get what? Negative 2.5. And then divide by the negative, which changes the sign, right? You have to be careful with that. This problem's taking up space. I gotta erase it. Over here, subtract 7. Negative w greater than or equal to negative 11.5. Divide by the negative. It changes the sign again. So w has to be less or equal to 11.5. So there's my range of values. So all the w values, given that they have to be in the range of 2.5 and 11.5. Okay. Once again, could I just take the 7 pounds, add and subtract the 4.5 to get my ranges? Yes. Not the point of this problem. The point of this problem is, can you write the inequality that works with it? Okay? That's the important part. That's it. Okay? If you have any questions, please email me. It's no problem. Hopefully this works. And this is something that makes sense to you. You know, why are we switching the sign? Why is there 2 cases? And we discussed it at the beginning of this unit, and now we're discussing it again with the inequalities. Okay? So have a good day, guys, and I will see you in the next lesson. Take care.